Hi, this is David Gornoski, host of A Neighbor's Choice and Things Hidden podcast, as well as some of our other programs like Science and You with our Chief Science Advisor, Dr. Yu, and our Seed Oil Survival series that we continue to have great fun unpacking the truth of nutrition. I wanted to give you a quick little message saying we appreciate all the support that we get from our uh, monthly contributors and our one-time donation supporters. And we'd encourage all of you to go to our website, a neighborschoice.com, click on contribute, and make a monthly pledge today, whether it's $1, $5, 15, 20, 50, whatever you want to do. Doesn't matter. Just be a part of building this new media project that we've developed to empower and inform, to inspire, to kickstart a scientific renaissance, an anthropological breakthrough and reformation in the church. All these things are possible with your support right now. So make that commitment today and help us keep doing the productions that we have. Thank you. Well, today we're back for another Science and You episode on our A Neighbor's Choice catalog. Our Science and You segments are where we dive into the world of physics and science news or science topics. And I'm your host, David Gornoski, here with my Chief Science Advisor for A Neighbor's Choice, Dr. Yu. How you doing, Dr. Yu?
Oh, I'm very good. Thank you for having me today.
It's great to have you on again, and everybody's still talking about that Wright Brothers anniversary special, the way you demonstrated the the truth behind gravity. What is gravity? And use very clear demonstrations to kind of show what gravity really is all about. But joining us today for our conversation is a guest that I thought, he sent me his article that I'd made a comment about how so much of, I said, physics is fake on Twitter, and I'm still trying to get a hang of how to be pithy on Twitter, because I'm a little bit of I can talk a little bit. What happens when you're in talk radio? You can go, and I'm trying to learn the art of pithy little points on Twitter. So I said physics is fake, and then my guest today, Robert Nielsen, he sent me a post on his blog, Living Voluntary, which is about peace, persuasion, and prosperity. And he sent me this piece in response to my post saying, rescuing physics with philosophy. So Rob, how you doing? Thanks for joining us.
I'm good. It's a pleasure to be here. Thanks for having me.
Yes. Now, for folks who are, people know Dr. Yu, he's a physicist. He's been on our program since the beginning on our radio show format, and he continues with us on the online format. But for those who are not familiar with you, Rob, tell us a little about you and your background.
Well, I'm not a physicist, which when a lot of people encounter some of what I write when it comes to science, use that against me, I suppose. But that doesn't mean I can't think and learn. So physics is a bit of a hobby of mine. I'm actually a professional educator. I work for an online university, and I've been in online education and training for years. But I'm just a really curious person. I have a lot of diverse interests. So when I find something that interests me, especially something that doesn't seem just right the way it's being taught, I like to dig in and find out what's really going on.
Well, great. So let's start off with your piece. You first start off with the statement, reality check, the standard model of physics is wrong. You say the standard model of physics is wrong about the nature of light, matter, gravity, electricity, magnetism, space, and time. You say the general theory of relativity is hopelessly and fundamentally flawed. Quantum mechanics is a mystical cult. Photon particles and electron particles do not exist and have never been the input or output of any experiment, let alone the virtual photons conjured to explain magnetism. You say most field theories are dead on arrival because they can't define a field without resorting to circular abstract concept reifications, fairy tales about wave-particle dualities that float in an empty nothingness called space-time that has no attributes but can somehow also be bent or outright indeterministic obscurantism. Very, you didn't really beat around the bush there, did you?
Tried to get right to the point.
Yeah. So tell us a little bit, kind of expound on these foundational statements here, wherever you want to go, just to make your point.
Yeah, well, 100 years or so ago, there was quite a series of controversies in the world of physics, and two of the figures kind of on both sides were Einstein and Tesla. And Einstein is known for his theory of relativity and the photoelectric effect, and among other things, of course. But in order to try to explain some of what was going on with light, they were trying to use the old Newtonian idea of there being a stream of particles. And I remember listening to Dr. Yu's conversation that you had before, kind of debunking that idea, talking about, well, light is really more of a disturbance in the medium. It's an environmental perturbation. It's a vibration. And so that's what Tesla said, and Einstein and people who were kind of promoting some of those theories had to basically deny the fact that there was anything in the environment to vibrate. So they said, well, we'll say that the environment is something called space-time, and we won't really go into what that means, except to say that it's a sort of empty nothingness, and that you can, but then gravity can sort of bend it, and that's what causes all this stuff. And then they used a bunch of fancy math to try to prove their point, but those models were flawed. And so my point about having to go backwards to go forwards when it comes to physics is we're going to have to get back to this idea that the environment is not empty. There is no such thing as nothing, and that light is not a series of particles. It's a disturbance in the medium, which is why, of course, that its rate of induction can slow down in things like glass and water and then speed back up magically without breaking the laws of physics, because it's really just a matter of that elasticity density ratio of the medium and how the pressure waves will propagate through it.
Dr. Yu, any thoughts on this?
Yes, very good. Yes, yeah, you touch the fundamental flaws in this called photon theory of light. Yeah, and so you mentioned about the elasticity in the medium. Yes.
Yes.
Hey, just curious, what make elasticity of the medium? What's the force make it elastic? You know, you are absolutely correct. Okay, I just wanted to make sure understand. So how do you think about this?
Yeah, well, this is another one of those tricky things. The medium, when we say the medium, I mean the medium could be multiple things, but in the absence of what we call matter, the medium has been known as ether for a long time. You can call it what you want, I suppose. Science has a bunch of fancy sounding names that they use to try to describe it without admitting that it's there, that there's something is in a place where matter is not. But your question about what is it that causes the elasticity? Well, every substance has an elasticity density
That's
ratio.
correct. Yeah.
And so whatever the ether is, whatever you want to call it, it has an elasticity density ratio that allows a high frequency pressure vibrations to propagate at what we call the speed of light, even though there's not something moving through the medium, it's the medium itself propagating those vibrations. Like I think you mentioned in your previous conversation, sort of like ripples on water. I mean, you can call it however you want. It's a disturbance in the medium, and that again, when those waves propagate through different media, when they go through the ether, they say the speed of light in a vacuum is what they call it, right? So the ether vibration will happen at that rate, but then when it happens in water or glass, it can slow down, which is how refraction, causes a lot of interesting visual phenomena that we're very familiar with, but seem kind of mysterious if you think, well, how come these photon particles are flying around in here, and why are they not cutting right through the back of my head if they're flying so fast when they get into my eyes and all those things? There's a bunch of silly, obvious contradictions in the idea that light is somehow this particle that floats into nothingness, but it's also a wave, because a wave isn't a thing. A wave is how something moves. So the something that moves has to be there. The environment has to have some elasticity in it, or else it won't vibrate. So I don't know if I answered your question appropriately, but yeah.
Oh, okay. So yeah, you are answering. So what I try to say, instead of using ether, I know ether lots of controversials, right? Mystics, but I would use a different word. Say it's a magnetic fluids, magnetic gas. So basically, so the so-called in order for light to transmit, you have to go through the it's a magnetic field, right? Electromagnetic field. And what form the electromagnetic field? I would say, hey, this is a fluids. It's a magnetic fluids formed by magnetic particle. And regarding the elasticity, when you have all the all the elasticity formed due to magnetic particle interaction between attraction and the repulsion. So I have the model. Do I have that one? So Oh yeah, let me show you. I try to answer this one. So, so why things have elasticity? So now I made this one. You see, use like campus type. Did you see? So each of them is a magnet.
Right.
Hypermagnet. But if you see, if I rotate one, everything else rotates with them. This is due to magnetic attraction and repulsion. So that's what form the magnetic form elasticity. You are really expensive. So basically that's confirmed. We do have a elastic. It's a magnetic medium, and the magnetic medium, because the magnet has attraction repulsion, so they create elasticity force, which in order for something vibrate, you have to in the elastic medium, right? So you are right. In order to transmit, you have an elastic medium. And what force causing elastic medium? That's the magnetic force. Yeah. So
Yeah,
very good, very good. We are all in agreement. Yes.
I might use slightly different words to describe what you're saying, but I think we're onto the same general idea. The medium is a dielectric medium. It's highly polarizable, which is, like I think you mentioned what you called magnetic attraction and magnetic repulsion, which is tricky for me because I try to be careful about the word magnetism, because I think to use it in the sense of expansive pressure and compression can be confusing to people. So I try to mention what we would call the compression factor. I call that dielectricity. I got that from C.P. Steinmetz and other people who called it that. He said there was a dielectric field and there was a magnetic field, and when they conjugate together, we would call that the electric field. And it was unnecessarily complicated to try to describe them with the same words, I think. So just in that sense, yeah, you can call it magnetism that caused the elasticity because the dielectric medium is polarizable.
Very good. So now you are you are pointing to another mistake in the current physics. So that's why all the physics theory point out the so-called electric field versus magnetic field. So there's I know there's a confusion about it. So, and what is the relationship? So based on so you may see my book sometimes. I will point out the so-called electro field, like a dielectrical field or whatever the field, right? So those are the conventional way they think about it. Those are the natural field. So all the magnetism come from the motion of this dielectric field. So that's conventional way, and I saw that that's exact problem with current physics. So they are inverted. The true relationship is electro field, electromagnetic field is the only fundamental force or field. And I would say, hey, magnetic field is the natural born field. Electric force is just a moving magnetic field. This is, if you're familiar with James Clerk's Maxwell's equation. So the so-called electric field is a derivative of magnetic field, right? So that means moving, time varying magnetic field. So basically, I try to say, hey, in my future languages, all the electric field is a dynamic magnetic field. So called a dielectrical field, like common say, hey, those are all due to motion of a magnetic field. So but that's another way to say. Of course, right now people have a sharp divide between electrical and magnetism, right? But I'm trying to unify them. It's all due to magnetic field. You can think this way. We never see natural electric field, right? We only see natural magnetic field. The reason is the magnetic field is a stable form. And when the magnetic field in motion, in vibrating, in motion, now you create called induction, right? Now you create the electric field. So electric field is a transitional, is temporary, unstable form of a magnetic field. So this is I just try to share something I'm working on. So I hope that makes sense to you. All the electric field is actually due to magnetic, due to motion of magnetic field or something. So that's why if you and the electric field is always temporary. However, it is more stronger than magnetic field. When you something in motion, right? Just like object stay stationary, stay still, stay in rest. You do not see energy, right? But once the object in motion, now you have you have what is a linear momentum. You have momentum, right? Now you have energy. You can do work. So that's why electric field appears so stronger than magnetic field because it's a magnetic field in motion. I hope that makes sense to you.
Yeah. The relationship between electricity and magnetism has kind of been fascinating. Like you mentioned, Maxwell and others who've trying to tackle this problem and help explain it. I do think it's important. I try to be careful about using the word field because a field is like a wave in the sense that it's not a thing. It's a description of a pattern in a medium, right? So when we say that there is an electric field, what we mean is there's a pressure pattern in the environment, or there's a magnetic field, there's a pressure pattern in the environment. There are movements and pressures, but there's not something in addition to the environment that's causing it.
Okay.
So it's a kind of a philosophical point, but it trips people up because people start to think about things in terms of positive charges and negative charges and certain kinds of spin and all this stuff. And I think the words can get in the way so when we say that there is a field, what we mean is there is a pressure pattern in the environment that can be observed, like you mentioned. And I think one of the interesting ways to observe it these days, I've seen videos on YouTube, shout out to Ken Wheeler. He does a whole series of videos using something he calls a ferrocell or a supercell, which uses it's like a little glass lens or two lenses pressed together, and in between them there's a very thin layer of ferrofluid, and when he brings magnets near it, you can actually see the shape of magnetic fields and how they interact with things. It's very fascinating. So if people want a visual representation of what dielectric and magnetic fields look like around the objects that we call magnets, I think you could check out the ferrocell videos on YouTube that I've seen. It's very interesting.
Very good.
I want to continue in your piece just for conversation.
Sure.
Mystical quantum confusion. How did we get here? You quote Richard Feynman saying, "I think I can safely say that nobody understands quantum mechanics." I thought Dr. Yu wrote that, but that was Richard Feynman. Right? Here's another one. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. That's another quote by Richard Feynman. And Rob, you say nobody understands quantum mechanics because it is a series of incoherent fairy tales and abstract concept reifications. When their models did not match up with observable reality, physicists 100 years ago decided that instead of rejecting their flawed models, they would create an imaginary world where their models could be true. Not content to simply deny the existence of a medium in which waves propagate and swap out frequencies and boundary conditions for massless particles, quanta, they went on to create all sorts of magical, quarky virtual particles to explain away the nonsense and spooky actions of their dogmatic fantasies. The mind virus of charge-carrying particles has gripped physics ever since. I thought quantum mechanics is foundational for our modern world, Rob.
Well, descriptions aren't explanations. This is one of the this is why I titled the post "Rescuing Physics with Philosophy," because if you ask for what's going on and someone describes something to you, but they don't explain it, and you accept that description as an explanation, then they can get away with all sorts of things. Like, well, if quantum physics is wrong, then how come it predicts all of this stuff? It's like, well, it's simply a way of describing something. It's not the reality itself, and it certainly doesn't provide any explanations. And this is actually one of, I guess my next, probably going to get to this in a second, but my point about mathematics, how physics got lost in it, was that math is a language for describing things. Math is not a language for explaining things. Math doesn't tell you what something is. It's just a way of describing the patterns that are observed. So people that like to say, oh, well, just, I want to see the math work. And it's like, well, I can make a model and I can make the math balance out, but that may or may not actually describe what's really going on. There could have fundamental errors in it that go unchecked because people accepted the math as the fundamental reality instead of what it's describing.
Well, I call that equationism, where it's like,
There you
this
go.
kind of it's a kind of epistemological error that you must show me your equations before you say any statement about the physical world, which is a very bizarre way to start the conversation. The physical world should be demonstrated through physical objects, and explained through, observable evidence, not just, like you said, starting off with fantasy land equations. But why do you think that that has become such an entrenched foundational dogma of physics, the quantum mechanics, and all the things that have spun out from that?
Well, like I said, 100 years ago, the great controversy sort of sided with the Einstein way of looking at things and saying, well, the das Lichtquant, or the light quanta, the particle of light, this idea, the whole quantum physics idea and the standard model are based on the idea that light's a particle. And so once you get past that and you realize that's not true, it's like, well, then there's probably a whole lot of other things with this quantum thing that aren't going to work. And once they started inventing particles to explain pressure phenomena, it's like a blind person sitting on the edge of a beach and feeling waves lap up against their feet and saying, oh, a wave particle just hit me. It's like, well, there aren't waves in the water's waving.
Yeah.
So if you say, well, yeah, but I can feel it, I can observe it, right? Even though they're blind, they can say, I can feel this wave lapping up against my feet. And you say, yeah, there surely is a phenomenon you're observing, but it's not explained by the fact that there's a wave particle in the water that's bouncing off of your feet. That's simply pressure in the medium. This is back to that idea that sure, you can water has an elasticity density ratio. Waves propagate through it at certain speeds. And when you observe that or sense that, you have different kinds of sensors. A lot of the people say, oh, well, then how come I can detect a photon or this kind of thing? It's like, well, photon detectors are actually something that they say absorbs photons. So these photons come and go, they disappear and come in and out of reality. When the truth is, a photon is just a way of describing the frequency of a light vibration. Higher frequency vibrations of a shorter wavelength will have more energy per second. You will have more wave impacts per second, if you want to think about it like that, than a longer wavelength with a shorter frequency. So again, it's not always that they're 100% wrong. It's that they're describing something. They're taking pressure and they're saying that pressure it exists in a nothing, and then it's also a particle, and it's incoherent nonsense. So once you start breaking that down, you say, well, if light is not particles and this whole quantum theory is based on light being particles, then they had to do things like invent virtual particles. You mentioned Richard Feynman. There's a video of him on YouTube. It's kind of famous. He used to do these conversational sort of documentary films on TV, and they would ask him interesting questions, and he would, he was a clever guy, and he would kind of with a smirk and a smile explain things. And they asked him this I think a British broadcaster guy asked him, so what's going on with a magnet? And he stumbles around and tries to explain it and ends up saying something about if an old lady slips on ice, what does that mean? And he gets kind of trapped because he can't really explain it. And what they did was they came out with these virtual particles, and the point was, well, they definitely don't exist because we can't observe them, but it's our way of making our equations balance. So we started with a conclusion. We started with an equation. In order for our equation to work, there had to be a something that we could count. And so we created this we said they were particles instead of vibrations in the medium, and that's how they started to get around all this stuff. And and if you break that particle, there's these other particles. Well, yeah, waveforms can be refracted and reflected and amplified and all of those things, but that's just a matter of fluid dynamics and understanding how wave phenomena work. That's not a matter of, oh, there are actually these particles floating around a magnet. They talk about gravitons sometimes. Well, gravity must be particles pushing on. They must be flying around and whizzing around. And when you realize, well, if that was true, wouldn't there wouldn't you have collectors for these sorts of things, and you could collect them and show them? And it's like, well, no, they get absorbed by the sensors. Well, that's a tacit admission that they don't exist in the first place as objects. Sorry if I went on too long.
That's okay. Dr. Yu, any thoughts?
I wanted to add one quote from Richard Feynman. So you quoted, that those things. When I do a lecture, I always talking about the quote from Richard Feynman. Say, anyone who claims to understand the quantum theory is either lying all crazy. Have you heard of have you heard of this?
Yeah.
Yes,
Yeah,
right.
he was a clever guy and he said a lot of interesting things, but I think he was obviously misguided in trying to kind of use this theory to as a substitute for actually talking about the realities of things. Because once you are a credential professional and you want funding, then you have to kind of go along with the way things are told, the stories that are told. And so
That's right.
again, you can explain something with a model that's flawed, and the thing that you're explaining or observing could be real, but you could be explaining it improperly, or failing to provide an explanation at all, for that matter. And certainly all of this virtual particle stuff is admittedly fake, but also photons. I in a separate post on my blog about light, I talked about what's called phonons, because some people talk about sound in this same way. They say, well, there's essentially these phonons, but we all know there aren't sound particles in the air that are entering your ear. Those are vibrations in the medium, and the structure of your ear will resonate with those vibrations at frequencies within a certain bandwidth, as you know. Similar to the eye, the structures of the eye, human eye, will resonate with vibrations in the medium at a certain and within a certain band, and outside of that band, they don't work. We humans can't see infrared with their eyes. They can't see ultraviolet with their eyes, but those can be observed, and you can observe those phenomena, and you could call them dark light, or sounds you couldn't hear, like a dog can hear different sounds than you can. Are those dark sounds? Are they phonons? Well, no, these are all ways of explaining things without just going straight to the point and saying, well, this is what's really happening. And they go, but we needed something to balance an equation. Well, fine. Why not call it a frequency instead of a particle? Well, that goes back to that argument 100 years ago, and someone had to win and someone had to lose, and Tesla said Einstein was wrong, and
so you
physics
come
has
from
been trapped by that ever since.
You're influenced by Ken Wheeler. This is the gentleman, I think he's the one that does photography, right?
He does a lot of photography on his channel. He also does a bunch of physics and philosophy stuff, and he wrote a
book. Do you agree with everything he's saying there with his paradigm? Because I've seen a few of his videos a couple years ago, but yeah.
Well, I don't agree with him on everything, likely. Yeah. I mean, I don't know everything that he thinks about everything.
Well, I mean his fundamental claims about physics.
But yeah, I think fundamentally he's on the right track. Absolutely.
Right. And he comes from kind of that Tesla paradigm, right? That there's
yes.
like a school of thought that comes from that. So I think the fundamental disagreement, I still want to focus mostly on this article, the pace of which you're doing to show where we agree and why.
Yeah.
But I think the fundamental disagreement, right, it would be between, I think Wheeler rejects particles, right? Atomism. He calls it atomism. And he kind of has more of a Platonic philosophy about this. Is that right?
I think so. And he could probably explain that from his point of view better than I could. But the idea that there's a substance, again, we can call it the environment, the medium, something. There's a substance in the environment, and it is polarizable, and it can be in the terms of people like Maxwell, they used to say they would churn it up, but it can be polarized and worked with, and when you do that, it does things that seem kind of baffling to humans. But in the same way that you would try to explain to a child that water, ice, and steam are the same thing, trying to explain to them that you could create what we might call a particle or a quasi-particle out of pressure in the environment. But just like a hurricane in the environment there isn't a hurricane in the environment is in a pattern of a hurricane. It's moving as a hurricane. It's kind of the same thing with matter and what you might call ether, or the environment, the medium. It can take different forms based on different kinds of pressure patterns that are in it. So
there is no particle, there is no atom, or what is the
well, there's only one substance. And again, you can call it whatever you want. You can call it ether, you can call it quantum foam, you can call it neutrino C, you can call it whatever. It doesn't matter what you call it. The fact is, waves propagate through it, so it exists. And that also means, like Dr. Yu said, that it has an elasticity density ratio, and that when pressure patterns move through it at certain frequencies, it behaves in different ways and is observable in different ways. So a high frequency standing wave configuration that we would call matter, or a mass particle, it's like that's not something in the ether. Just like when you boil a pot of water, air bubbles will appear at the bottom and rise to the top. We call them steam. And you say, well, what is that? Well, it's water. But it doesn't look like water. It's not behaving like water. It's moving against the way you expect water. Water's supposed to go down. Well, this is going up. Well, why? Well, you can explain all of that with all of the understanding of pressure and movement, and like Dr. Yu was saying before, these things are a matter of pressure and movement. So Is our water, ice, and steam the same thing fundamentally? Yeah, in the same way that the whole universe is all the same thing fundamentally. It's just under different temperature, pressure, configurations, and patterns in different locations, and so it seems like it's different. Ice isn't floating in water. Water is floating in water. At the, or steam is in the air everywhere. Or there's some trace amount of water even in really dry places that it's in the air. But it's not, having it distill out of the air like dew. It's like, well, where did this water come from? It's like, well, it's all around. You've been breathing it, but you can't see it with your eyes until it condensates.
Dr. Yu,
So
any
I guess
thoughts?
matter is like high pressure etheric condensate. If you want to think about it like that, it's in a pressure configuration that it becomes essentially visible and has the phenomena that we're familiar with associated with it.
Oh, David, you wanted me to comment on?
Yeah, go ahead.
Oh, okay. Sure. I want to comment on one thing about we just mentioned about the wave particle duality, the light.
Mhm.
Yeah. To be simply, I was very critical at the time. What is it? 20 years ago, 10 years ago. Simply because those physics at the time not truly understand the wave and the particle difference, and so they do not have a clear definition. So that's why I mix everything together. Also does not truly understand the nature of light. I believe so. That's why. So when you're not sure for one thing, what do you say? Hey, it could be both, right?
There you go.
Yeah. So
It's an
that's
equivocation. It
Yeah.
could be both, and then we don't have to argue about it anymore. Yeah.
That's right.
Yeah.
So I wanted to understand. So you find that these are ridiculous. Do you have your thoughts on where the physics went wrong? Where did they went wrong?
Well, abandoning the idea that there's a universal medium underlying all these phenomena,
Yeah.
right? As soon as you say there's a
Excellent.
nothingness, but we can bend that nothingness. Tesla said, well, bending a nothing is about the dumbest thing you could say. Like, if a nothing has no attributes, it has no properties, you can't act upon it. It won't react when you try to experiment with it. So as soon as you get out of this idea that, well, if waves are propagating through a location in space, then there must be a medium that's mediating that pressure. As soon as you abandon that, then you're off track, and you have to start inventing a bunch of other things to make it work. I know we're talking about light now as opposed to matter, but you could think of matter in this paradigm as high energy standing waves of light frequencies, of EMR frequencies. Once you get past gamma, then the light frequencies become so intense that they'll collapse in around themselves and spin, and we call those protons and neutrons. And protons and neutrons are essentially the same thing, but they're under different. A neutron is essentially a charged proton, but that again, we're getting kind of off topic. I don't know how far you wanted to get into the matter stuff today, but it's all the same stuff. There's only the environment and pressure in the environment. Those are the two factors that you're working with. Like, you can name them whatever you want, but the patterns are there, they're observable, and that's what we've got to work with.
Rob, you definitely hit the problem with modern physics. So they deviate from the medium. So that means light carrying medium.
Right.
Deviate that one. So that's why it comes after or quantization, or all kind or relativity theory and quantum mechanics. So, however, even for me, the mistake made even in the classical physics. I just try to. Have you noticed any mistakes in classical physics? So include James Clerk's
Maxwell, et cetera.
Maxwell equation.
Yeah. Well, I mean, even going back to Newton, who was a brilliant man. Even Tesla refuted what we call Maxwellian ether and Newtonian light particles. So saying that there's an ether doesn't mean that anybody who has anything to say about what's in the environment is right. There's people that can still argue about, well, what is that? What is it then? What is the environment? What's in it? And how does it behave? And using reason and experimentation to get there was the Tesla way to do it. He'd say, well, pressure propagates based on the elasticity density ratio of a medium, and if it's propagating through the ether at this speed, that means its elasticity density ratio is XYZ. And he would use the math to prove something, but he wouldn't use it as a foregone conclusion or as something to chase with a bunch of made up ideas. He said, well, look, the facts are the facts. We can back into it if we can admit that. And so the fact that someone like Tesla, who certainly had a lot of respect for people like Maxwell and Newton, when we say classical physics, are there errors? Well, sure, they're trying to figure things out. Newton was wrong about a stream of particles, and Maxwell wasn't right about what they called a fixed bed ether at the time, that it was sort of a solid, and that if we moved through it, we could feel the resistance. There's things like the Michelson-Morley experiment where they kind of tried to prove this idea of the ether by measuring that, but then you don't realize that's like floating down a river and putting your hand in the water and saying it's not moving. Well, yeah, it's moving right along with you, so you're probably not going to detect it in the way that you're trying to detect it at this moment. You're going to have a perspective that's going to allow for that. So
you also so what's your I did not I read your article online one. I did not remember if you touched the gravity, or I may miss that. So what's your interpretation of Newtonian gravity?
Well, I don't probably know enough to say about Newtonian like exactly what he would say about it, but I think going back to Tesla said we should call gravity universal compression, because it's a better way of describing what it actually is, rather than just sort of saying, well, there's something that kind of like pulls things down. That's sort of from the perspective of a person standing on a planet, which isn't the case in most of the universe. Most of the universe is not a person on a planet. It's what modern science kind of says is empty space or a vacuum, but is really filled with the universal medium, and that universal medium exerts pressure against itself and everything else. And so that kind of compression, that universal compression, I agree with Tesla on that way of understanding gravity. And it being essentially the opposite force of the one that we describe with the word magnetism, or I think you called it magnetic repulsion. So those things are always in some balanced ratio with each other in different kinds of pressure patterns and conditions in the universe. And depending on where you are and the pressure conditions you're observing, they might seem more or less mystical to you, but in the same way that a 5-watt light bulb and a 5-watt laser have different effects and different features and attributes, that's the same with like things like magnetism. What we call a magnet, I think this is a good example. If you had like an iron lump that was not quote unquote magnetized, what's the difference between that iron lump, that pre-magnet, if you will, and once it's been magnetized? What's actually changed? People don't usually think about it this way, and they say, well, this one has more of these invisible particles floating around. It's like, well, you could say that it's really more like a matter of focus or coherence or point source sort of phenomenon. So the pattern, the larger pattern, when you sort of zoom out and look at a magnet, you can see that the shape of the magnetic field using things like a ferrocell, or even the old iron filing sorts of experiments. They put iron filings on paper with a magnet. You could sort of see, depending on the way the magnet was oriented, how the filings would align with that pressure condition that we call a field. But oh gosh, where was I going with this?
The difference between a lump of iron and magnet.
Gravity. Yeah, and the difference between the lump of iron and magnet. Well, there's no more magnetism in what we call a magnet than there was in the pre-magnet. It's just been electrified into coherence. So it's kind of like focusing light into what we call a laser. You've focused what the magnetism there that was incoherent. It was sort of randomized, I guess you could say, with all the little pieces. I think, Doctor, you mentioned this too. Like all the little pieces are essentially magnets. That matter is polarized, and so when you align all of them, all of the fields exhibit this larger macro field behavior. And just like the old fasces in the ancient world, where they would have a stick. If you take a small stick and you try to break it, it breaks easy. You add another stick and another stick, it doesn't just get additively more difficult to break it gets multiplicatively more difficult. So a multiplicative macro field will appear in a place where you've sort of electrified a coherence into it. And it's like having a focused version of that lump of iron that was there before. And now it's coherent. And if you were to melt it, then you would lose that coherence. Things would get more random again, and the magnetism would disappear. All those virtual particles would just disappear. But really, you're just observing the fact that pressure condition is no longer a coherent and point source in its configuration. It's now more randomized. But it will still behave the same. If you try to push against it, it will react. It'll have elasticity and resistance when you try to touch it or pick it up.
Yeah. I want to comment on this called the ion, does not appear magnetic behavior until you put in the, the electromagnetic field, right? And so the reason of, I just gave my interpretation, say, the reason ion does not appear is because if you have the net, in my theory, is everything made by magnetic particles. But the natural state, the most stable magnetic states is if you have let's say two bar magnets, is opposite pole attract. So that means one north and south. So they are in contact. So then what happens is the neutral state, and that's the most stable configuration of all matters. So that's why mostly we will see, hey, all the matters appears magnetic neutral, right? So that's because that's the natural state of magnet. Two magnets opposite, then you neutralize entire surroundings. So the reason for ion to be magnetized is because when you have a stronger external magnetic field, what happens? It break the natural neutral configuration magnets and flip them away. So now they become a stronger magnets. So now the whole iron bars from the neutral state and suddenly flip because of external magnetic field. Now it becomes all flipped and becomes stronger magnets. That's the nature of the. And I also want to make sure the audience get an answer when I ask you about what do you think about gravity, right? Newtonian gravity, and you explained it well. But I just want to give audience my clear answer. Say, hey, the Newtonian gravity, which means unidirectional pole, only attract does not exist. Everything we observed attractions, we attributed to gravity is actually the magnetic attraction. So Newton's gravity is just part of a magnetic attraction. So that's my answer. Okay.
Yeah, and I would use different words, but I think we're on the same track there. So like, I would say that magnetism is about repulsion. So when I talk about what you say magnetic attraction, I say dielectric acceleration, but similar idea. Gravity is just an incoherent kind of randomized form of dielectric acceleration. And so when you sort of focus it and you align those fields, like you said, then it becomes what people might call magnetic attraction. But that's just a coherent form of the same thing. That's just gravity. If you want to think about it this way, that's just gravity acting in a focused way, like as if you had a lens, like a laser or a looking glass or something, right? When you take the sun and you burn a hole through paper, you can focus the light, just like you can use techniques to focus the pressures in and around a magnet to behave in a certain way. So yeah, it's the same. It's all the same sort of fundamental principle. And to your point, if every particle of what we call matter was not polarized or magnetic, however you want to think about it, then things like MRI machines wouldn't work. That's how they work. They use a large magnet. They use a large magnet to align all the little bits of you into a certain frequency. I mean, they know the frequency of all the different pieces, and they can make an image out of that when they run a magnetic field. We say a magnetic field, even though that's just a pressure pattern in the environment. They can run that pressure through your body, and every little piece of your body will align with the magnetic field in different sorts of frequencies, and they can say, oh, this is a hydrogen atom, or what you might call protium. It's a single proton. Well, it has a certain frequency that it wobbles at. It's precession, and so the MRI machines are set up to detect that. And again, these things seem like magic. There's no particles like going through your body and coming back to your eyes and giving you notes and disappearing.
Yes, I want to go deeper on the subject. You mentioned the MRI machine, of course, is magnetic imaging, right? So
Right.
long magnet. So and you also mentioned about we can make an image out. So I want to make that point. Why we can make an image out? So the image is actually from an electromagnetic wave. So where comes that wave? Is because every single particles in make our body. Okay, there are magnetic particles. When you have a machine create a vibrating dynamic motion in your body, what happens? Every single cell, every single particles in your body vibrates, and that vibration creates lights. That's why you can image that.
It's the R in MRI. It's the resonance, right? All the little pieces even will resonate, just like with a sound.
Of the body, the particles. And
Sure.
why the body particle can resonance with the electromagnetic field? Because they are made of magnetic particles, electromagnetic. Okay.
Yeah, I mean,
so that's why
the same way a glass will resonate with certain frequencies of sound, right? Or if you have tuning forks, right? If you have a tuning fork and you make a certain sound, the tuning fork will actually start to vibrate in resonance. So
that's
the
a
same idea. Light, sound.
That's an electro, that's a pressure wave. Yeah. So the human body responds to electromagnetic field. So that's because that every single particle is a magnetic particle. So that's, of course, they were oscillating with magnet. And that oscillation, that oscillation create lights, right? So that's how we got the image.
That's what light is. If it gets within a visible spectrum, we call it light. If it's outside that, we call it things like X-ray or gamma or infrared or ultraviolet.
Yeah.
But it's all vibrations, some of which your eye structures will resonate with, and some of which they won't. So
exactly.
Yeah.
If you do not respond, so you're not resonant with it, just passing through. You do not have that signal. Yes.
And this is actually, not to change the subject, but this is actually also why radiation is so dangerous for people, because high frequency radiation from radioactive materials will actually cause this very, very fine structures of your body, like molecules, to rip apart. Because it's such a high frequency, those parts of your body will resonate with it, and they'll break apart. They'll be destroyed. They make you sick and you die really fast. That's why high frequency energy, old EMR,
cancer.
light waves, it causes cancer because it breaks you apart. It breaks you into little pieces, and it causes errors in your encoding and in your DNA and in all the little substructures that make up your cells and things like that. So the size of the wavelength of gamma radiation, the wavelength is very small. It's so small that it will cause those atomic structures to vibrate enough to break apart molecules. And so that's why it's so dangerous. It's not just that it's like hot, like that it warms you up and melts you, but it'll break your substructures apart, and your body can't repair itself fast enough. So
I'm curious, just a little bit off topic, but you pull from Tesla's paradigm, and you mentioned Ken Wheeler, who's built on that, a lot of these concepts. Does that worldview fit with the electric view of the universe? The electric
sure, but again, like people who claim like electric universe theory, they could mean anything by that. I mean, some of them probably disagree about a lot of this, but electricity is a hybrid of dielectricity and magnetism. It's a phenomenon of pressures of both evening out, right? So you can't have electricity without both dielectricity and magnetism. And the electric universe, that's like saying
you can't have the Thunderbolts project, or I think it's what it's called.
I've seen some of that, and in some cases they're right, but in some cases they're pretty excited about the idea that it feels kind of magical, and they want to sort of explain away a bunch of complex things by saying, oh, it's just electricity. But you say, okay, well, what is that though? Is that electrons flowing through like metal, or is that really more of a pressure condition that gets reflected around certain materials? So electricity doesn't happen within a material; it happens in this what you might call the space or the counter space around it. So yeah, the universe is electrical. That's like saying the universe is a universal medium with pressure patterns in it. Those pressure patterns can be observed as electricity because they'll alternate between compression and rarefaction, right? The stretching and squeezing, or the compressing and expanding sorts of things. If you can harness and reflect those around certain materials, that's what we call electricity. So is everything electricity? Is everything ether? Sure. I mean, but that doesn't mean everybody who says, "Oh, electric universe" is right about everything they say, because
Right.
they disagree about things sometimes.
Yes. David,
Similar to, if I may really quickly, Doctor, to your point, it's actually, whether you call it electric universe or you might call it magnetic universe. You seem to like approaching it from a magnetic point. It's sort of the same idea, right? Everything is based on these kinds of pressures. Sorry, please continue.
Oh, okay. Yeah. So for the EU, I just want to make David aware. The one thing, electric field, I agree many macroscopic explanation with them, because your electromagnetic phenomena too. It's fundamentally, for me, fundamentally agree with my the only natural force as a magnetic force. So that have no much difference. But the things they kick me off is when I believe the founder explains, say, hey, electron. He explained electron is a miniature solar system. Do you remember see those pictures?
To see pictures of electrons?
Oh, yeah. I believe that's the founder, present that. So what he think of what the electron is, he put an electron just like a miniature atoms, solar system. Say,
you're
hey,
talking
electron
about
has internal structures. Did you see that one?
Are you talking about J.J. Thompson?
No.
The atom. You're talking about something else.
Universe.
Electron
universe.
Okay. I may or may not have seen that. I don't recall.
I have a picture. I can show you. When he's so I thought, well, apparently he's not understand electrical deeper enough. So that's why I thought, okay, so they do have a limitation. But a lot of experiments they did. Explain the macroscopic phenomena we observe daily. Of course, I agree with them. So so that's a EU. So they do have a fundamental flaw in their understanding the real world. Hey, I noticed, Rob, you mentioned about the electron does not exist. So what is the electron in your opinion then?
Well, the electron is a unit of dielectric discharge measurement. So in the same way that you could, if there were a flowing body of water next to you and you put your hand in it, and then you lifted your hand out, and you could say, well, I felt the pressure. Something must have pushed my hand as it went by. But just like there's not a wave in the water, it's just the water moving. It's a measurement of pressure discharge, which is, the pressure is there, and then they say, well, it only appears when you measure it, kind of a thing. It's like, well, yeah, that's like saying, if you throw something at me and I can only measure it when I catch it. So I don't know if that answers your question directly, but like, what is an electron? It's just a measurement of pressure. It's not a pressure discharge. It's not a little BB that's whizzing around and that bounces off of things or whatever.
Yeah. Yes.
Okay, there we go. Elegant simplicity of the electric universe.
Yeah.
Wallace Thornhill.
Yeah, Thornhill. Yeah, that's
okay. I see this now.
You see now, all right? Let me show you next picture.
Okay,
that's his
presentation.
Yeah. Did you see electron is a miniature
sure
solar system? Yeah. And also he pointed to the proton. So that's where I thought, oh, okay. So their understanding does have a limitation. So I just want to make sure. So that's why David always asks me, is this your theory? Like basically the magnetic universe, right? Does your theory agree with electron theory? I said fundamentally we have a difference, but macroscopically, because in my view, electrical field, the electrical universe is a manifestation of a magnetic particles, magnetism. So that's why that's the difference. However, if you dig deeper, oh, okay. So his understanding of electron, the reason I wanted to ask you electron problem, I believe that's the fundamental problem in physics. So that's why I ask you. And you did say electron does not exist. So now what I want to say, hey, we do have a particles, right? We do have a particles different size. So what electron for you is because, for electrical field, theory, electrical theory, that's this group universe. So they believe electron actually is the miniature like a solar system or atom, which is this is a very significant. That's current physicists are also confused with this one. So David, we interviewed Brian Greene, right? Yeah. So several years ago. You know, Brian Greene is, right? He's considered like a founding father of the string theory. He claimed he's a string theory, but he really is a defender of standard physics. That's in particular, it's quantum mechanics. Okay, so in our interview, he said he does not understand what the electron is, and the reason he said that way because he said if electron is really something without the internal structure. Without something, he said, how could the emergence of human consciousness and eventually human life? You know that, right? So based on those things, he started. But I told him, I said, hey, electron for me is actually just a little magnetic particles. And he said, oh, I believe he said makes sense. Is that right, David? He agreed with me.
No, he didn't. He said we're not allowed to question that. He told the radio.
No. Yeah, when he said not allowed questioning, that's the other part. Yeah. That's when we're talking about quantum mechanics. Fundamentally, I told him, I said, you know, strong force, nuclear force does not even exist. Yeah. He suddenly jumped in and said, hey, he said, no, that's not, he said, we have evidence, you know, they are exist and something. Yeah, that's that. But when I mentioned about it, so the reason of the electron does not have an internal structure. However, we consider elementary particles. That means particle does not have a substructure, substructure other than it is, right? So that's why he said, oh, he said he never heard of it, but he said, yeah, that makes sense to him at the time. Yeah. So, Robert, what's your explanation of emergence of consciousness?
Oh boy, we're going into metaphysics instead of physics
that's
today.
That's too big a topic, right?
Yeah, well, the origins and nature of consciousness aren't really a physics question, and I guess that's why mainstream science refers to it as the hard problem, because it's not one that you can solve with the technologies we have and our understanding of how to observe the physical universe, what we call the physical universe. I don't really have much to say at this point about the emergence of consciousness. I would say that I'm confident that it's not an emergent property of matter. It seems to me to be the other way around in some shape or form. So I think I don't think consciousness just happens because matter is there, and so therefore consciousness decides that it wants to exist and is going to exhibit its will somehow. I think consciousness is a precondition for all of that.
That explains well. So you are a strong Christian, religious person, okay?
Sure, I find no flaws in any of Christ's teachings. That's for sure.
Oh, okay. I'm not saying there's a problem. Okay, I admire David is the whole family.
Sure,
is Christian family. So I just want to give you my scientific answer about the what is consciousness.
Okay.
So. You may never heard of this one, okay? Because that's part of my theory, and I'm the one saying, hey, the so-called consciousness is awareness of existence, yourself, okay, or over distance of the environment, right? It's awareness. So what things can make people aware? Self and over distance environment. What's that thing? Magnetic field. So that's the property of the fundamental particle, which I proposing every single fundamental particle possess not just mass and occupy space, it possess magnetic field. Magnetic force, I would say magnetic force. So that magnetic force so allow you to sensing yourself, because every other particles in yourself is magnetic particles. And also all sense environment, say interact with the light. Light is electromagnetic vibration, right? Wave motion. So how can you sense wave motion? Because That's the propagation. That's a field, vibration field, magnetic field. That's where you're sensing those light, because your every single particle in your body is interact with this electromagnetic vibration. So the so-called consciousness is just a ability. So that's called awareness. It's ability to aware yourself and the environment and that interaction through magnetic force. I hope that makes sense to you. Yeah. So
Yeah, I'm okay with broadly describing consciousness as awareness. You can have different levels of awareness, just like you can sort of have different levels of consciousness. I think this is to go back to the kind of religious description. I think this is described in a lot of ancient religious writings about kind of levels of consciousness. A lot of the descriptions about animals and things like that, the level of consciousness that different animals might have, and the way that they perceive and observe and exhibit their will on the environment is different. So
every particle has consciousness in my definition.
yeah, okay. So if everything is aware of everything, and again, aware, using that just as a generic term.
That's how particle can interact with the magnetic particles, magnets, right? In certain environment. And that's how particle can connect each other, right? If trees, you touch a tree, you will leave marks, tree has a consciousness too, just a different type. Yeah, just say you said a different level. Yeah, that's
yeah.
right.
So you can be aware, just like a child or an animal, a dog knows what hunger is, even if it can't explain it, and it knows what food is, and it knows what another dog is. It doesn't really know. It doesn't really know what an interest rate is. It doesn't know what next year is. It doesn't know what death is. When you get outside of the physical world, you get into the consciousness realm. You start talking about levels of awareness and understanding, and that becomes complicated because humans are the highest consciousness that we're directly aware of in the world, and so it seems like we're the top of the chain. But when you start thinking, well, consciousness isn't an emergent property of matter, and there are higher levels of consciousness than humans typically are aware of or are able to exhibit. So yeah, I mean that's a very open question.
Now, Doctor, you would not say that consciousness is an emergent property of matter, though. I've cornered you on this before.
Oh yeah. Oh yes, of course.
See, I had to get this out because I didn't want to sign up for atomism either, Rob. So
I know.
I told him, I said, we're going to go on this journey together. You're going to have to admit that that is not an emergent property of matter.
That's all right. That's all right. That's just my
well.
perspective.
You don't though. I've asked you. I said that consciousness is coexistent with matter. It's not a downstream emergence from matter, right? You would say matter
consciousness is
part
of the matter. In my definition, the matter possess not just mass and the volume.
Matter does not precede consciousness in your model of the universe, right? It exists eternally with it.
No, the matter possess magnetic force. And the magnetic force is the consciousness, is the interaction.
Right. That's your explanation of the interaction, but force is coexistent with matter in your model. There is no matter and then force comes down as a downstream effect.
That's right. Yeah, they are involved. They are the same thing. If
now,
you
Rob,
have a matter,
you have a we're going to go down a rabbit trail here, but Rob, I am open to the idea that matter could have in some sense eternally existed, but I don't know. With God, I mean, God, if you think about it from the Christian standpoint, mind and body seem to be kind of essentially important, unlike other religions which put an emphasis on mind over matter. Does that make sense? The incarnational concept of Christianity puts the idea of matter being just almost elevated to the same level of spirit. So I don't know. To me, the idea of matter and force being eternal, kind of, maybe there's a way that works with the Christian cosmology, but not sure.
Yeah, sorry, and that. So I didn't mean to interrupt you, Dr. Yu. Please go ahead.
Oh, I'm sorry. I don't want to create this divide between normally, what is godless people with religious people. Okay, that's not my intention.
No. All humans are religious, Dr. Yu. The question is what you're in awe of. That's the question.
Okay.
All atheists are religious.
What inspires you, and what do you want to seek to emulate, right? What is your highest value thing? I don't know if it's exactly a question, but just to speak to your thought there, David, I guess it's,
Because you don't accept the Big Bang, right?
well, so the Big Bang, interestingly, I was actually going to point out the Big Bang. The Big Bang came from a Catholic priest.
Uh,
The
Oh,
idea of the Big Bang,
do you
and
do you
the
accept
idea,
that?
the idea, so not as it's probably understood or as most people would think about it. What I don't accept is that a something came out of a nothing.
Yeah.
So the ex nihilo idea of creation, right? First there was a nothing, and then there was a something, and then the something just kept going, and then yeah, like that idea is silly to me as the idea that waves could propagate through a nothing, or that you could bend a nothing, or that that a nothing has attributes. This is kind of back to the Einstein idea, but the Big Bang idea came from a Catholic priest, and it was kind of latched onto by some people who thought, well, this is a great way to explain some things. But well, so what happened before the Big Bang then? I mean, when you
Right.
start zooming out far enough, you get an eternal perspective, and you say, well, whatever is and has been. That doesn't mean it's
Right.
always in the same conditions and always in the same
Right.
situation.
Right.
But what
I don't think it's heretical, Rob, to say that maybe something like matter has always existed as part of God's godness. I don't know. Why does it
well,
have to
well,
be? Why do we
has
have to say in beginning the
yeah,
heavens and the earth? What does it have to mean that matter did not begin before that? I mean, in some sense, does that
exactly.
make sense?
Well, and to get into the creation story,
Yeah.
I think it becomes self-contradictory if you look at it as a literal story in that
Right.
regard, because they'll say like, well, this was the first day, and it's like, well, what they're talking about the first day happened before what they said the sun existed or something. So it's like, well, the whole thing is obviously meant to be a symbolic teaching, and
Right.
people like to the literalists of all types like to jump in and say, well, no, it has to mean this exact thing because I say so, and it's like, well. Um, Otherwise what? I mean, I guess from the point of like a religious conversation, I would say it doesn't really make much sense to me to argue with people about, well, whether or not this means this or this is literal or that's literal, because everyone's going to say, well, this one's symbolic because I don't really believe that would be literal, but this one's literal, and
Right.
they'll
Right.
start to go through and parse the scriptures with their own understanding and their own
Well, Rob, all,
preference.
all I'm saying is since we opened up that can of worms, I don't
Yeah.
think. See, I think this idea that the Christian theological alliance with Big Bang cosmology is a Gnostic mistake because it perceives it disorients this idea of like mind is all that exists in God, and then from that is an emergence of matter. But incarnational Christianity would say body and soul are intertwined in a way that is mysterious, and that's a difference. That the pantheists believe that everything is divine, and then you got these other religions that kind of have concepts that distinguish everything is an illusion. There is no matter. It's all just an illusion of the mind. And I think Christianity is distinct from both of those. I don't think it accepts pantheism. I don't think it accepts Gnosticism and this mind illusion. We live in a matrix world. But so much of Christian theology has aligned itself with Gnosticism. And that's, in my opinion, that's one of the fundamental mistakes about why we're stuck in a rut with physics. Is because you've got so many Christian theologians taking the backseat to these foolish atomistic, and then it starts off with atomism, but it ends up being this occult mysticism, like you talk about in your article, where it's like mind. It's this kind of this detachment from the importance of matter. So theologians say, okay, Big Bang, that solves that matter. We're out. We'll take the backseat to this, and I think they should have challenged it from the beginning because the Word is eternally begotten, and the Word is I think there's something about. I don't understand why that is heretical to say that something like a matter has always existed as part of God's Godhead. I don't have a problem with that. If he's eternally begotten, eternally enfleshed in some sense, I don't know.
Well, I mean, I guess you could try to explain something to a child like we talked about before, like the water ice steam idea,
Yeah,
and you could say, well, has ice always existed?
yeah,
Yeah, not necessarily as ice, but when you start to zoom out, you start to see, well, there's this whole series of cycles that
yeah,
cause it to go through different states, and the fundamentals of whatever it is, sure, those continue,
yeah,
but it takes on different preferences. It takes on different not preferences, sorry, different pressure conditions. That's what I meant to say.
yeah,
Um, and so ice has always existed, but it hasn't always existed as what we call ice. In that same way, I would say the observable matter in the universe sure, it has always existed. It will continue to always exist. It won't always exist in the same conditions, though. Like there are big bangs, if you will, in the universe. I mean, there are supernova. There are lots of things like this, but those are parts of cycles. You can't jump into a cycle and say it starts here.
Right.
It's a cycle. It's
Right.
it's the universe recycling itself. These pressure
Right.
conditions. If something gets large enough that it has to break apart and then forces bring it back together and it breaks apart again, that doesn't mean that it didn't exist. It just didn't exist as you know it.
Right. I just wanted to clarify the point that Dr. Yu's model of the physics universe does not invalidate any of the truth claims about Christianity, about the world.
No.
And whether he agrees with it or not, it doesn't matter. There's no contradiction to, in my opinion, the cosmological outlook of Christianity and his model. But it doesn't necessitate, I guess you can make more of an atomistic kind of interpretation of what Dr. Yu's implications are about the universe. But I just wanted to put that aside because my audience probably has wondered that. I haven't really addressed that in a while. But I want, for the audience's sake, to understand what we've been describing. We've all agreed now that, in this discussion, just to reiterate, we all agree that the foundations of conventional mainstream physics are fundamentally flawed. We believe that relativity, like you said, hopelessly in error. Quantum mechanics is mysticism, right? There's a lot of foundational flaws. Dr. Yu's model goes into different direction than I think the model. Do you have a name for your model? I mean, you use philosophy. As soon as when I read your article, I immediately thought of Ken Wheeler, right? And because I remember watching some of his videos a few years ago. And I remember thinking, man, he gets pretty close to where Dr. Yu's going, but there is some deviation. I would say that in the realm of skeptical of establishment physics, there seems to be the two biggest things going is something like this Tesla-derived dielectric view, this thing that Ken Wheeler and you are talking about and Tesla's talking about and others. And then there's this electric universe, which deals with the macro scale, the big macro cosmology. And Dr. Yu's model is in its own little world, and it's kind of only being developed through his work that he does lecture wise and the work that he does on this program. So we're in a little bit of an island situation, but hopefully that'll change soon. But I just want the audience to understand the lay of the land here, right? We have this kind of Tesla electric model of and I'm Rob, I'm not going to do justice to reiterate to in my own words that model yet. I'm not as familiar with the language, but I've heard when I was reading your article, I was like, is this guy reminds me of this guy, the bald guy I remember. I'm not saying it to insult, beautiful head,
sure.
But the guy that I remember seeing on YouTube, and then you said the name, I was like, oh, that's it. He goes by Theora, or what is it? Some kind of
Theoria Apophasis, I think, is the name of his channel. Yeah, and again, he does a lot of photography and stuff there, which is great.
Yeah, we'll have to. I've emailed him before. I think we'll have to try to see if we can get him on the show or something. That'd be fun, and that'd be to continue some of these topics. But and then you've got the electric universe theory. So whenever Dr. Yu makes criticisms of the establishment field of physics, ends up, if they're not familiar with Dr. Yu's model, they end up trying to place him into the electric universe model or this Tesla kind of world that you're talking in. And Dr. Yu's model is a little distinct from both of those, but there's a lot of overlapping observations, it seems like, just to kind of put a bow on what we've covered so far today.
Yeah, I think sometimes the words get in the way. I mean, if someone says magnetic attraction and someone else says dielectric acceleration, or someone's, it's like, well, fundamentally we're talking about a sort of counterspatial pressure, right? A compression in the environment, which we agree has a degree of elasticity and density to it. Otherwise, it couldn't propagate the waves. Like, well, the words can get in the way sometimes, and I think we definitely agree on a lot of the fundamentals of what we call the standard model has wrong, because they in denying that there's a medium and in inventing a bunch of particles to make their equations balance, it's led people to this idea that there's such a thing as a charge carrying particle.
Yeah.
So again, the words get in the way. It's like, well, a charge carrying particle. So there's a particle, again, like I think most people would think of something like a BB, right? Like a small sphere, and it's somehow carrying a certain flavor or color of charge around, and then it passes it to other things as it goes by. And this is the trouble with models, like, you know, the old saying that all models are wrong, but some are useful. I mean, that sort of mentality is like, well, who cares if the model's wrong? I was talking to someone once about some of this electron stuff, and he said, well, who cares if there's electrons or not? There's electron behavior, and so let's just move on. And I thought, well, but it actually does make a difference, because fundamentally, if you understand what's happening, then you'll be able to use that knowledge to manipulate the environment better than someone who just accepts a flawed model.
Dr. Yu, why are you, I mean, if there's so much overlap with what you're saying and what this Tesla electrical dielectric model of pressure and all this, why not just, like, same thing? Who cares? Why not just accept the Tesla paradigm? Is that not sufficient?
Yeah, that paradigm is still can refute some of the problems in say modern physics, but you know, the fundamental problems go deeper than that. So they go deeper than Nikola Tesla's understanding. So that's why I try to develop the theory. Say, hey, all
Be careful,
the
Dr. Yu. Just like there are idols in the establishment physics world, there's idols in the anti-establishment physics world too.
Yes, you know, I asked Rob about it. So the problem actually go beyond the modern physics. You know, so say, hey, because we dismissive about the medium axis, right? Medium for carrying light. So that's create a problem for modern physics, no problems. But I find out even for classical physics, so we have fundamental problems. And so for Newton's law of gravitation, so that's where we created this called dark matter black hole and the dark energy, because that's fundamental problems with Newtonian's gravitational theory. So that's why I try to say, hey, so the Newton force does not exist. It is actually a magnetic attraction. We always see the attraction part is due to magnetic attraction. There is no such called unidirectional, only single directional, only force in this world that does not exist. So basically, I try to say all matter not only attract, but also repel. Yeah, the reason is all matter has a magnetic force. So that's the fundamental reason. So that's one reason I mentioned. About another reason, you know, the current theory talking about this is called strong nuclear force, weak nuclear force, besides our gravitational force. And I find that those forces are redundant, does not exist at all. So basically, when you dig deep into what is the fundamental particle, you know, Newton's theory never mentioned about the particles, right? Never mentioned the fundamental, what a particle is. You know, the Democritus, you know, the old Greek philosopher. So they mentioned about it, but however, they define atoms indivisible, the smallest indivisible, particles, object. So does not mention about fundamental property. That's bother everything, all the phenomena, all the electricity, light, all this heat, all these processes missing from our classical understanding is because that model does not include magnetic force as part of fundamental property in the atoms. So that's where it's missing. So what I'm trying to deeper. So if without the magnetic force, everything mechanical particles, where comes consciousness? Where comes the life? Why everything can interact? You created this gravity force. Gravity force is so weak, it's zero force. Compared with any electromagnetic force, it's 10 to the 36 power less than, if you have a paycheck. If you round up, the 6 digits after zero, it's a zero, right? This would be 36 zeros, and then you shoot up gravity. So gravity does not exist in any quantum mechanics, in quantum mechanics discussion. So they still have a standard model. Hey, we can have a model, but without any word mentioned about the gravity, because gravity is invisible, it's zero in that theory, right?
Right.
So
They don't account for gravity, and they to their credit, they generally admit that
yes,
they've been trying to square that circle for a long time. They can't fit gravity into quantum physics, and so that's why I said they propose things like a graviton. They say,
right.
well,
That's
if we
where
say there's a particle, we call it a graviton.
hypothetical particle.
Yeah,
They said, well, yeah,
they're up to the same old tricks trying to explain it. Yeah.
that's right.
Yeah, I mean, going back to your article, some more quotes that you have here. Edwin Armstrong says they substitute words for reality and then talk about the words. I think this goes back to the philosophical dimension, right? This seems to be nominalism at play, right? This idea that names define things versus like realism. Would you say that's clear?
Yeah, and that's what I guess that's what I was trying to say. Sometimes the words get in the way, and so
Yeah.
like trying to define your terms and understand where people are coming from. If magnetic attraction, so-called, and dielectric acceleration are the same thing, then we don't need to get hung up on the terms. We can say, well, there's a compression force, there's an expansion force. If you call them magnetic attraction and magnetic repulsion, I guess so be it. That that may or may not work in the long term with other things, but that's fine. The fact is, those two pressure directions, that sort of like spatial direction, the expansion of something, and then the compression of something, that's counter spatial vector. Those are clearly forces that exist. We can measure them, and together in different sorts of arrangements and proportions, they account for all this stuff. So, like Doctor, you said, it's redundant. I think that's a good word to use. It's redundant to say, well, you've got this weak force and this strong force and this nuclear force and this gravity force and this electric force and this magnetic force. It's like, well, there's really only one kind of force. There's pressure.
Fundamental force. Yeah.
Okay,
You're right.
like pressure,
So
movement.
Rob says it's
something to
under
that
pressure
effect.
by the WHO, and Dr. Yu says it's magnetism, right?
That's right.
But magnetism, but what is magnetism? I mean, like to describe it by its effects would be to fall into that trap of.
So Rob, let's give him the same question you
Sure.
asked people. Don't explain it. What'd you say? Don't describe it, explain it, right?
I said descriptions aren't explanations. So like to say that say that something.
Explain magnetism, Dr. Yu. We're going to put you on the hot seat now.
Oh, okay. So magnetism, I believe that's it's a natural property of matter. Okay, and now it's natural property of matter. So what is the natural property of a matter? So now we have to describe the phenomena. It attracts, likable, repel, unlikable, attracts, and over without the direct contact, right? So I know, Rob, you are thinking straightforward, just like me. However, you adopted this dielectrical acceleration, this concept. What does that mean?
Well, it's just a description of the same force in the opposite direction. So, like you said before, so like matter is kind of funny when you think about it, because it's sort of attractive, but it's also repulsive at the same time, right? Like all matter doesn't collapse together, but it also doesn't just float away. So what accounts for that? Well, there's these two directional forces. Matter is sort of like pushing and pulling at the same time, if you want to think about it in simple terms. And the pushing and the pulling, you could call magnetism and dielectricity. You could call them attraction repulsion.
Do you have to define what a dielectrical acceleration is? I believe if you present any theory, you have to have a term fundamentally natural to people, to the world. So do you have to define that term before you explain the use?
Sure. Yeah. And dielectricity is not my term. I didn't invent it. I got it from reading Charles Proteus Steinmetz's work, where he talks about the dielectric field, the electric field, and the magnetic field, and how the electric field is a conjugate of the two. And that's why when you have something that's both compressing and expanding, then you get an interesting pressure pattern that we call a torus, which is really the model for mass particles in general. They're both, compressing and expanding at the same time. In a sense, they're in a balance, in a sort of standing wave configuration. So when I say dielectric acceleration, I'm just talking about that universal compression. Again, you can call it gravity, you can call it, right? It's all that same force. It's that idea that of counterspatial coming together, and then magnetism would be the opposite.
Or an explanation?
Well, I'm describing its effects, but I'm also trying to explain that it's a part of a conjugated system, right?
Yeah.
So you can't have a push without a pull. can't have an up without a down. You can't have a left without a right. You can't have an in without an out.
Yeah.
So in a very simple terms, dielectric acceleration is a fancy way of saying inward.
Yeah.
And magnetism is a fancy way of saying outward.
Yeah.
So inward pressure, outward pressure, if you want to use like the simplest terms. So
Rob, I believe you mentioned about Occam's razor. Yeah, which
Occam's
I
razor,
do
sure.
believe.
The
I do
simplest
believe
explanation
that's
is likely
yeah,
to be the true one. Sure.
to be the truth. That I do believe that's a fundamental principle for
Sure.
our passing our judgment. Yeah.
No reason to unnecessarily complicate things. I agree, which is why inventing a bunch of particles to explain something doesn't really work. You can say, well, there's a compression, there's an inward pressure, and there's an expanding outward pressure, and the outward pressure, you could call it radiation, you could call it a lot of things, but again, radiation only exists as a conjugate to induction. Right? Different materials, for example, we know will either radiate or conduct or induct or reflect or refract. All of those are descriptions of how the waveforms will interact with each other. And if we reify the waveforms, if instead of saying, well, those are descriptions of pressure in a medium, we say, no, they're now something else. They're this whole new dimension, and they exist as a bunch of little BBs that fly around because we like to count things. That leads you to weird conclusions. If that
Dr. Yu, what do you think?
question.
Do you have BBs flying around in your model?
No.
I hope they don't fly around into nothingness if they do fly around.
I do agree with David talking about the Big Bang. I just say, hey, I don't believe a Big Bang ever existed. You cannot, hey, create something out of nothing, right? So
Agreed.
I believe we are all on the same solid ground. Yeah.
I would say. Oh, sorry, I didn't mean to interrupt you.
Just add another thing. The matter, I believe matter exists from the beginning to the end. So there is no beginning, no end. This is in my explanation. So it's not created by that. So I do believe the conservation of matter. So matter cannot be created or destroyed. It only can be transformed. So I do believe this one. So
it's interesting. It's interesting, Rob, that Tesla came from an area. His father was a Orthodox priest.
Mm-hmm.
And a lot of orthodoxy was and still is influenced by Neoplatonism.
Sure.
And I wonder if that's the rub here. Not that who's wrong or right, but Dr. Yu's model seems to be more comfortable with atoms. And this kind of Tesla-derived model that you are working in seems to be more not interested in supposing eternally existing material atoms, right?
Yeah.
Is that
well? It's like saying do waves exist? And it's like, well. It's like saying, do waves exist? It's like, yes, as a pattern. They're not a thing. They're a pattern in a thing. So, you could do atoms exist? Yes. Are they a pattern? Yes. That's what I would say. I would say atoms are a pattern in the universe, because the universe is everything. It's funny because people will describe the universe as expanding, and I would argue, what is it expanding into? Into the nothing. There's a something that came out of nothing, and it's expanding into that nothing. It's like none of that makes any sense. There's just everything.
Yeah.
That's the universe, and it has observable attributes and properties. And when you under different pressure configurations, it manifests as different things like matter, light, electricity, etc.
Well, we're gonna have to leave it here, folks. It's been a fascinating discussion, and Rob, thank you for coming on in short notice. After you sent me that article, I said we got to get you on. So just to have dialogue partners is very welcome. And I'm glad. I want people to read that article on your website, livingvoluntary.com, Rescuing Physics with Philosophy. We'll put a link in the description below. If you're watching on video or audio platforms, you can find it there. So thank you, Rob, for your time. And you're on, I think, it's good to know, there's a lot of common agreement within the world of people that are talking about these things. And do you think with Tesla's model, elemental transmutation at room temperature is something too, by the way? I wanted to ask you that before I let you go.
Well, so temperature is one of the things that is connected to everything else. So you've got temperature and what we call states of matter, and you've got radiation. I mean, all of these things are in balance with each other to some degree. And so what can be done at room temperature? I don't think we know the limits of that, at least
So
ultimately.
So under the Tesla paradigm that you're kind of working under, that you could theoretically have, room temperature elemental transmutation from one element to another.
I suppose I couldn't explain to you how that would work, but I could see it as a possibility. I mean,
See, Dr. Yu, that's where it's going to have to come down to these evidence that we're going to continue to investigate on this show. If you have a battle between two paradigms, not that that's the big battle. We've obviously got a bigger battle of the establishment physics, but that's kind of taking care of itself in terms of legitimacy. But what's going to emerge as the new paradigm, it's got to have explanations that you can predict about the physical world with your paradigm, with your theory, and make hypotheses, and then create scientific evidence that supports that hypothesis. And I think that that's where the work has to be done at the end of the day. Besides the explanation, besides the logic, Dr. Yu's theory, I asked him when I met him, I said, tell me some things about the world that's possible that your theory would predict to be true that, current models would not really point to. And he pointed out things like elemental transmutation at room temperature, and he gave his explanation for why with magnetic particles. He pointed out things like anti-gravity propulsion. He pointed out things like, room temperature, energy, nuclear energy that's room temperature, what they used to call cold fusion.
Reaction, kind of nuclear,
low energy nuclear reactions. So these are things that have to be explored, and then whoever's model can most accurately predict these observable phenomena, and then make those, and then use those as a map to bring those pieces of evidence into existence, I think will be the theory that wins the day. So let's see what happens in the future. And I really appreciate your time, Rob. Very good stuff. And I want people, again, to check out your website, livingvoluntary.com. And of course, if you want to be in touch with us at A Neighbor's Choice, you can email me hello@aneighborschoice.com. I'm David Gornoski. Godspeed.